Now, part B of 2011 higher level U value question is as follows. It's quite a common question that gets asked, especially if they ask a question giving an old wall. What they'll want to do then is, how do you improve the U value? So in this question, it's proposed to upgrade the terminal mass properties of the wall by fitting expanded polystyrene to the external surface. Now, this question, you're given conductivity, so we're given conductivity of this. The expanded polystyrene, which is 0.037, so obviously it's got a very low conductivity because it's polystyrene, which will help with the U value. Now, the question is, calculate the maximum thickness for this expanded polystyrene to achieve a U value of 0.27. So to achieve this U value of current building regulations, what it is, we have to calculate how much insulation we have to put onto the outside of this wall. So to start off with this question, the first thing we do is we take our new U value, we write it down as 0.27, and the first thing we'll do is we'll actually change it back to resistance. And there's a reason why we're going to be changing this back to resistance, and you'll see in a minute when we look at the first part of the question. So to change this back to resistance, first of all, this is how we calculate the U value formula. So if we rewrite this out with capital T equals the U value, so we write down 1 over RT is equal to 0.27. Then RT is 1 over 0.27. So RT is equal to, we get our calculator, so we get 1 divided by 0.27. So the answer we're getting here in the calculator is 3.703. So 3.703. So it's 3 decimal places. So now this here is the total resistance of this new wall. So it's a good idea to write down total resistance and new in brackets afterwards, so that you know that's the new wall. Now, if we refer back to the previous question, we're looking at the total resistance here, and this is the total resistance for the old wall. So if we put in old here, so the only difference between the two answers there is, logical enough, the resistance of the actual plaster or of the insulation. So by taking one away from the other, we'll be left with the resistance of the insulation. So if we do that now, so if I write down total or resistance total old in here, which is equal to, from the previous part of the question, 0.640, we'll take RT new minus RT old will be equal to R, and I'll write down insulation here because that's the only difference between the two walls, is this insulation. So we write in our figures. So all we do then is put our total resistance new and minus our old resistance. So the answer we're going to get there is 3.063. So that is the resistance of our insulation. Now, the next stage then is we draw our table. Now, this table only is 2 rows, but we'll put in our 5 columns again as per usual, and just get in a habit of doing this. So the first part is component, and this time the component is just the insulation. Then the thickness we're looking for, we'll put in multiplied by small r, resistivity, divide by K, conductivity, and capital R. Now we're going to fill out our table with the information that we've either found or that we're given. So for thickness we don't know, so we're going to put in an X here. It's a small bit of algebra to work it out. Then multiplied by resistivity, we're not given resistivity in this question. Now we are given the conductivity. So the conductivity of this expanded polystyrene is here. So we write this into our table. So we write in 0.037, and then we'll write in the resistance. So the resistance that we've calculated from above is 3.063. So if we write this down then as it appears, X divided by 0.037 is equal to 3.063. Now we move this across the line, so X is equal to 3.063. And this time, because we're bringing it across the line, bringing over our divide sign changes to multiply. So it's multiplied by 0.037. So X, if we put it into our calculator then, multiply it by 0.037. So the answer we're going to get is here. So we'll write down this answer and we'll look at it. 0.113. And what we'll do, we'll go again 3 decimal places. So we go to the fourth one. So it's under 4 this time. So we leave it as it is. Now the answer we're getting here, this is obviously in meters. So we can change this to millimeters by multiplying by 1000. So the answer to this question is the thickness that we're looking for is 113 mils of insulation. And that's the answer to part B of 2011.